Good morning.
Here a minute. How are you keeping?
Oh, doing okay. Just been swamped. Lots of things going on. Actually, just recently also got engaged.
Oh, congratulations.
Yeah, thank you. Shaping up to be a very busy year. Also have a lot of contract work going on.
Yeah, because you were working for somebody else, but you moved on, is that right?
Yeah, now I guess you could say I'm working for somebody else's, and it's I don't know. We'll see how it goes.
Better than the alternative.
Yeah,
So Precision X is your company, right?
that is correct.
Good morning, Kevin, and good morning, Z.
All right.
Morning, Aaron. Good morning, everyone.
Morning, Andrew.
Hello, good morning.
Good morning, Michael.
Morning, Alan. Hey, everybody.
Good morning. Is it pronounced Key? K-E?
Oh, hi. Hi, this is Key from Marvel.
Hi, Key. Welcome aboard. Is this your first time?
Yeah, this first time, and yeah, we have some activity here, so I want to join the team to listen, to get some information here.
Yeah, no, thank you for joining us. Welcome aboard.
Thanks.
When we get started, I'll ask you to do a quick introduction, but hold fire until then. You said you were with Marvel, is that right?
Yeah, that's correct. Yeah.
A few minutes for people to get going.
Oh, I'm sorry. I think this is a HPC meeting. Is that right?
That's correct.
Oh, sorry, I was in the wrong room. Sorry about that. I was wondering why. Yeah, thanks a lot. I get into the wrong one. That's supposed to go to HTD meeting. Sorry.
Morning, Alan.
Good morning, Jeff. And good morning, Howard. Good morning, Nat.
Alan.
Okay, we're 8:05. Who we've got? Good morning, Trent.
Alan,
Yep,
do you have summary turned on?
I do. That's correct.
Okay.
Uh, is that a problem?
No, that's great.
Yeah, no. So the OCP, if any of you guys that are run these OCP sessions, there is a summary option. I somehow heard about it, or I asked about it, and the IT managed to enable it. Apparently, I think they get summaries for everything. But anyway, I managed to get hold of them. So it's not great, but it's a pretty good for anybody that doesn't want to listen to the entire hour conversation. It gets the general gist, but it does make some glaring mistakes. But as long as everybody knows, it's a nice little summary that I paste into the minutes each week. So it's been
And
quite helpful.
it does better than the straight transcript.
Oh, absolutely. And we do have the straight transcripts as well. And I give a link to the straight transcript if you wanted to, take that. So
No,
that's, I put
this
that in.
the
Sorry.
straight transcript is pretty terrible to have to go through and clean up.
Oh, no, it is. But the transcript is very good at capturing. It seems to recognize all accents. It does a pretty good job these days, actually.
Yeah.
But yeah, so it's painful to unless you're particularly searching for something that happened in the meeting. But between the two of them and the recording is fantastic in my mind.
Yeah.
It saves in my end at least, it saves a lot of work. So I just cut and paste the transcript in there.
How to access summary, after the meeting? Is it show up on the near the video, or
Say that again, Michael.
the summary, right?
Summary.
How do we get actually those
Well,
summary?
see, with my meetings, I actually put it into the minutes. So you
I
get
see.
a summary in the minutes, but it only goes to, well, in fact, I think by default it goes to the people that manage it in OCP, and I've got them to forward it on to me. So forwarded my copy onto me. So that works.
Okay. Thank you.
Okay. Okay, so just catching up on this here. All right, let's get going. All right, let me share my screen on the notes. you can see the minutes. Zoom in a bit, Sean.
I am with IR Labs, Alan.
That's Nat, right?
Yes,
I thought you were. So you were with Rambus, were you?
I was, but I have been with IR Labs for the last 3 years.
So when I just selected you just then, oddly enough, I did think, I could have swore he was with one of the optical companies. All right, let me just change that. I had a good conversation with one of your colleagues actually at one of the the photonics, is it in San Diego a few weeks back?
Okay.
Right, and let me just update you here as well. Forget. All right. Okay. All right. Good morning, everybody. So I don't believe we have Kidu came and went, so I don't think we have any. Actually, just on that note, sorry a minute. We've got 12 participants. I've got 12, and Kidu is left. So Jason. Good morning, Jason.
Yeah, this is Jason. Yeah. How are you? Yeah.
You joined. I didn't see you join. You snuck in there. Okay. Good morning. All right. I think I've got everybody. I'll update the sheet shortly. All right. Yeah. So just a quick update. Obviously, I had the OCP Regional Summit a couple of weeks ago. That went quite well. I managed to talk to a bunch of people, specifically in the thermal management area. So I got some interesting feedback on all of that. I think the presentation went quite well, and I think the actual contrast that we did, or that I did on the actual Blackwell, the NVIDIA Blackwell implementation, did hammer home the point, the way the architectures are radically changing. With the thermal management, they're getting rid of motherboards, cables, and the like. So, in the way that we've been trying to address that with our new approach, and also I think Blackwell does show that we are really putting a round peg in into a square hole with sticking with 19-inch racks. Maybe I'm a bit biased on that, but it does seem that way. So I think it does round out some of the details behind what we're doing and why we're doing it, beyond the presentation that I gave in the OCP Global Summit last October. And I think the two recordings together should hopefully give everyone a good understanding of what we're doing and why. For those of you that were on the last call, I believe the last group call we had, it was a good call with Bijan, the CTO of OCP, was on in a penny drop for Bijan. And he was saying, oh, you need to, can it do this? Can it do that? And I said, yes, it can. Look at the previous presentations. So he was getting the big picture. And he feels that, he feels that we can deliver the message a lot more clearly. So hopefully he's promised to work on, I've given him my slides, and he's promised to work on a more of a one that he believes will get some attention of the bigger guys. But another thing on that as well is I did actually present the same presentation at, I believe towards the chiplet group, the ODSA, and as well the CMS group, the composable memory systems. And it rang through that was it. Bijan was on the composable memory systems call when I went through it. And and it rang true with a lot of people there. So I don't know. In a lot of ways, you know, I have highs and lows on this effort. In a lot of ways, it feels as though with everything that's happening in the industry, with the way the technology is progressing, the penny is beginning to drop with the need to look at things differently. So that's good. The other thing that I'll come on to later today is one of the sort of requests. So because we're sort of seen, we are obviously high performance computing, then everybody looks at the, you know, beyond even what we're doing to the majorly exotic. So like the Cerebrus wafer scale, you know, single wafer chip. And as many of you may have heard in the news, that TSMC had one of their, I guess, their tech conferences, and they announced this wafer scale approach with discrete die, with the likes of the Tesla Dojo, that takes 25 discrete chips and actually puts them back into a die with a redistribution layer to wire them back together. And so in these wafers are in the order of 15 to 20 kilowatts, I believe, at the moment. So there's those. So I wanted to talk a little bit about the trend in there. But one of the requests I was really getting was, hey, can you do more than a kilowatt for the processor? Because that's everybody's trending towards 1.5 and up and higher. And I guess the wafer scale one came up as well. So I wanted to discuss that a bit later. But first, just on the our proposal that we've been trying to pull together. So that's been on hold. I think I did announce a few weeks back that it was now off hold. I did ping the Oak Ridge people, and they said basically the message they gave me was it's back off hold. They're working on it, and they expect to release the final RFP late in June. So we're in mid-May now, so we've got about up to 6 weeks, I guess, before we see the RFP. And then they originally told me companies will have 4 to 6 weeks to respond with their responses. So the clock is officially starting ticking now. In that sense, we do have a bit of time. We have, you know, the order of 8 to 12 weeks, I guess, depending on the exact timing of things. And so we've got to put the effort into to make this as polished as possible. The things that I've been doing with everybody's input in all the different work streams in what I did for the regional summit was really to put a bit more meat on the bone of the, I guess, the three out of the 4 primary activities, or sorry, 2 out of the 3 primary activities that we've been digging into. One of them being the universal interconnect piece, which we've been making some nice progress on with the interconnect guys on the work stream. The other is on the thermal side, in terms of the thermal management and the, you know, as well as the power delivery, but more focus on the thermal piece, which is the bit more challenging piece. We've got a very radical idea there of a 2-phase approach with water. Had lots of input, including from Trent and the likes, and so I put that together, and that was a good discussion at the regional summit. So what I was going to do is the extra detail that we've got. I'm a sort of a top middle person, whereas we need bottom up expertise, and the companies involved are the bottom up experts, shall we say, in the different disciplines. And so I've got enough intelligence now to put a bit more meat into the proposal from a top-down perspective. And so I'll try and shape the various sections, those 3 sections that we've got, into a bit more detail from a top-down perspective, and I'll try and put a bit more meat into the overall system architecture and introduction at the beginning to explain all of the lower level pieces. Additionally, on the system management side, although I didn't cover that at the regional summit, Munir was there doing some demos of what they've got going, and we've had some good progress in the work stream. I think with especially Jess on the call from Unified Point, I think that we've got a good little collaboration of diverse experts there where we can put a decent system management story together as well. So I feel as though, at least from a top level perspective, I can get a story together in the proposal that's attractive. I think the weaknesses that we've got are we still lack really a well-respected system integrator that could be the sort of the one throat to choke. Because I think we need a lot of participation from all the companies that obviously work on the different aspects of this across the various disciplines. But ideally, I'd like to be able to pull a complete POC together, where we can actually build a mini wall of HPCM modules and actually test something out and to test the various aspects out. That would be the ideal situation if we could get the funding. And again, just to remind everybody, with the different sort of efforts we've got going on in the thermal system management and interconnect, for example, I was hoping that if it was too much of a chunk for the RFP folk to bite off, or they didn't like every aspect of it, maybe they would be willing to fund one of the avenues, like the thermal one, for example, if that was an interesting thread to pull. So that was how I wanted to shape the proposal. But in terms of the high-level system integrator that I'm after, I guess our biggest hope at the moment is that Bijan gets the bigger picture. There are a number of people like this in CMS that's run by Meta and Intel and a chap called Manoj and Reddy. And I just get the impression that they're beginning to sort of see the uniqueness in how innovative what we're trying to do is. And maybe if we can get a sponsor inside one of those big companies, maybe they can offer some help towards the systems integration side of things, or line us up with somebody that can help with it. So I guess that's our biggest missing piece is a holistic system integrator that can really drive this. I was going to have another bash at IBM because they are so good on the open front and they are well respected by the government, and they have given up on HPC themselves directly. And they do have some activity going on in excuse me. They have some activity going on in OCP where they're working, I think it's Jabil. Well, not IBM don't, but Jabil are talking about putting a big memory system together with IBM's Power 10 processor, and in the DCMHS format, which is the server format, the open server format that Dell and the likes are working on. Now, the nice thing about that is one of our early modules, for those of you that have been here long enough, one of our early modules was a Power 10 with the OMI memory in E3 format. And so my thought process was, if they actually make progress on making that Power 10 server in OCP, then everything gets delivered into the open of making that server, and then we're a mechanical reformat of that into an HPCM module. And the other beauty there is on the system management side of things, there's a small company called Raptor that does 100% open source BMCs, and they've done it for power for a long time. And they work with Lattice. They have been doing the system management FPGA Libra BMC implementations. So potentially we could map that across the Raptor's efforts across into the module as well on that big memory system with Power 10. So I'm going to have another and the lady that runs Meow, the lady that runs IBM's Open Power consortium, that's part of this effort of trying to do this with OCP. I know her quite well, and so I'm trying to fold a bunch of people I know in IBM to see if I can have one more attack at them being this maybe the system integrator on pulling this together. Don't have high hopes on that, so don't hold your breath, but I think it might be worth one last effort. So so that's really where I stand. I mean, in terms of people here, I have asked the Oak Ridge National Lab people if we could potentially have another pre-meeting to see you know, what they'd like to see from us in terms of for us to maybe get their attention when they review this. I've got no response yet. So anyway, that's an overview of where I think we need to go. We're really going to need to get pen to paper. I'm going to, over the next sort of month, I think I'm going to be able to get a little bit of time to try and pull the framework of the document together as a holistic piece. But this is where you guys are going to need to get involved if you want to be part of the bid and part of the funding. If we're successful, is where we're going to need some real technical meat in there, including numbers of how much money you need. You know, what are we going to do? How much money do we need to do it? And we, you know, and we get collaboration across the disciplines to make it happen. So we need to get the story together on like a technical project plan almost of the activities we need to do in the various areas and who's going to do it and how much is it going to cost. So I'll shut up on that point and open it up to the floor. Any views on how we go about this, or anything at all on how we go about this response. With just one other thing, as in one of our last meetings, Jeffrey Mershon from Unified Point has highlighted a bunch of other funding opportunities that might align with what we're doing. So the only thing to bear in mind here is if we do put the effort into this response, I think, and we can make it as polished a response as possible, then if we're not successful with this New Frontiers one, we will have an opportunity to sort of you know, reskin it or whatever it needs to be done to put it into maybe a bunch of other funding avenues. Maybe, you know, there's a good few that come to mind, you know, on a single hand numbers ways. So anyone thinking of putting the effort in, what's the chances we might have a couple of shots at a couple of funding avenues. So back open to the floor, guys. What do you think along these lines? Is there any views on how we should go about this? And anybody, whatever topic on this response.
Yeah, I liked your idea of you going through and putting together kind of a high level, you know, framework structure within it, and then, you know, parsing it out to different folks to sign up for different sections. Typically works pretty well in these types of formats.
Yeah. Now, I need to ping. Yeah, Bob Ciotti, ex NASA, did offer to sort of put some words into it in terms of how to structure it. So I'll ping Bob again, see if he's got some time. By the way, if anybody feels they can help out from this top-down view of things as well, then please jump in.
I think there was a new list went out from the FWorks guys on SBIR, STGR opportunities. the other day, and there's probably some high performance computing in there.
Yeah, I think Jeff might have already highlighted those, right, Jeff?
I'm just trying to find the link.
Okay. We seem so it just in terms of progress, the interconnect one we seem to have some good discussions between the various interconnect companies, helping us nudge that in the right direction. So that feels good. On the thermal side, historically, we've had a lot of support over the years. Certainly, Boyd have been a big contributor in helping nudge things forward. I've had some good inputs from the various different cooling experts inside OCP that I've got to know over the last couple of years, and so that's been good for at least to educate me in terms of some of the challenges and some of the opportunities. I think there are certain bodies that might be able to get involved. In fact, in Europe, I was hoping that there might be some funding avenues in that direction as well, because they are a bit more forward thinking in the sustainability aspects over there. And like the government, so I think that, for example, the UK government, I feel, or European government says that any new HPC machine, at least a megawatt, has got to be of the energy has to be reused, or at least as 10% of the energy of the machine needs to be recovered and reused.
That sounds a bit like perpetual motion to me.
Well, 10% isn't perpetual. 100% will be perpetual motion. On the system management side, I think we have some good momentum there. Certainly, Lattice are making good progress out, even with their own efforts with open power, etc., and their commitment on the BMC side of the world as a company. And as well, Jeff from Unified Point on the call here I think he's got a good top level perspective on keeping systems healthy in a preventative way rather than wait until they fail. So I think we've got some good stuff in the system management. I've had various good conversations with some optical companies. I guess NAT and Air Labs, when I went there, when I saw you guys at the show, you've obviously got the historic AIB, the silicon interposer variants. I think I talked to one of the guys on the stand about the potential of having a standard PHY connected variant, but it didn't seem like that was on the roadmap. So anyway, an organic implementation. So Avicenna have expressed an interest in giving us some models, and the presentation I gave on the Universal Interconnect with a path to co-packaged optics was based on the public Avicenna information. I think they would be interested if we can get some funding. So, but they are obviously also busy with getting their own products out the door. So, as a small company, it might be difficult to keep their attention. All right, so by the way, on the system integrator side, we do have a startup called Teresa that's in Renew, has been on a number of the calls. It's sort of expressed interest and potential with partners to be able to do the system integration piece. So that one is still a possibility, but they have. I just believe that for that to work, we would need to get their external collaborators involved. Now they do have some good links with on the Indian side of things, because obviously India's ramping up pretty big on the HPC front, and there's lots of efforts there with lots of money flying around. But I'm not sure that would be applicable to funding. I think that you have to have a US entity, so I'm not sure if that would work for them being a system integrator. So what I'll be doing is I will be working on seeing if we can convince one of the bigger guys. I've been knocking on AMD's door and Intel's door a number of times, seeing if they could help us with this proposal. So
I think the problem with the big guys is they just do their own thing regardless.
they do, but
you know, I've been trying to tell them to do things different ways for years, and the common thing is they just ignore you because they're big guys.
That's right.
You know,
Well,
the small guys are a lot better. You know, Air Labs are more likely to work with you because like they're not big guys.
Yeah, no, I get it, right? But equally, yeah, I guess. Well, Pat Gelsinger keeps suggesting they are completely open and they're not invented here.
Well, I got that from Micron. The guy said, "Oh, we're completely open," and like, you know, no response whatsoever. So, you know, it's like, so, you know, generally when they say they're open, they're not. You know, it's the old RAC thing of advertise what you're bad at as being what you're good at.
Yeah, no, I'm with you, Kevin. Completely agree. Yeah.
I think your opportunity is probably in things like you know, NASA do, I think every year, but they're looking for better computing for like CFD and stuff. You know, so if you can actually build a machine which is like you know, 2 or 3 times better.
Oh my God! Actually, thank you there, Kevin. You've just put a light bulb in my head there.
Yeah.
I used to do an awful lot of work with the FPGAs with CFD about 20 years ago. Early 2000s, we made some great progress on the CFD codes. Well, great progress. It was a lot of work. GE Global Research put a lot of work into that.
Yeah.
And I still believe. In fact, I think they've done a big. In fact, there's a press release just the other day I saw on LinkedIn that they did a big demo on Frontier. I think it was probably one of the best use cases of Frontier machine. So. Mate, in GE, maybe I could get GE to front this. Maybe.
But I think the thing is with
they're more software people than hardware.
Yeah, but the NASA stuff is something where you get some amount of money and you get to be program lead on server stuff, and you then subcontract people to do things.
Right.
You know, there's a possibility that you get something working out at the end of it, but you know. It sort of follows the structure you're talking about, you know, trying to get people sort of to do bits and pieces for you.
Yeah.
I would still say that the opportunity for HPC is to try and pull in the optical communication stuff and get more communication.
Yeah. Well, if you look at the regional summit presentation I gave, I mean, hopefully that I've presented instead of a breaker switch of copper world to co-packaged optics, which seems like everybody's sort of, you know, trying to achieve, try and blend this world of being able to move between the two.
The problem I see is a lot of people are trying to do stuff with optics where they're using fiber rather than free space optics, and gluing fibers onto things seems to be the major issue.
Well, yeah, no, so we've got a bit of a combination of both. The free space optics is one that I've been looking at for the system management side, but lots lower speeds just for neighboring modules. So that'll feature.
It should be fast. I mean, there's the stuff at if you look it up at Stanford on the nano quantum photonics stuff. You know, if you got a huge amount of bandwidth, and the futures thing at OCP a couple of years back, people were talking about how much bandwidth is available because you can break down the spectrum.
I'm sure it is. All I was thinking is just in the architecture of what we're doing. I was just thinking that an easy button. Again, this would be with Avicenna. You know, they have these blue LEDs that are super low power, and they have hundreds of them.
Yeah,
all going at 4 gigabits per second or thereabouts. Well, just one of their LEDs at 4 gigabits per second, free space between over a couple of inches or less, a couple of millimeters between modules, is my system management mesh network that I was thinking of putting in to bring us out of the 1970s on the system
Well,
management.
there's a thing which is hard to do, which I don't know if anybody does at all, of like prioritizing the communications. You know, where you try and work out all the communication channels you have,
Yes.
and then prioritize them so that low latency ones go in particular paths. And
Well, that's why I've talked about control plane and data plane. In my mind, you get the elephant traffic off of the you have a separate network basically.
But I think you need to sort of factor that into whatever you're proposing.
Right. Well,
which is more it's a software and a hardware thing, which is what
it is, yeah. So what I've certainly got the hardware angle covered. The software is obviously a big one, but so to that point, I've always thought like this. You know, the control plane would be a packet switch control plane with small packets that can move anywhere very quickly. And ideally, the data plane would be a zero power data plane, as I call it, because it would go through optical circuit switches. Because what's the point in switching a packet every 64 bytes when you're moving a terabyte from A to B?
Yeah, I mean, nice thing about optical switches is they're like zero power.
Exactly.
Zero latency.
Exactly. I mean, that's been my whole point right from the beginning. Presentations I did back with IBM.
But there's a tendency that, you know, you plug in a computer and it's like wants to boot a BIOS that's like 30 years old. You know, to get going, and like, so you have to sort of fit it into that world, or people just don't know how to use it.
Right, exactly. Well, and I think you know, all HPC machines tend to be synchronous in the end, anyway.
I think, I mean, we're going to sort of locally synchronous, globally asynchronous. You know, and I think one of the things is like the IPv6 world has not really arrived yet. You know, people sort of treat IPv6 a bit like IPv4 when they're thinking about it, and really, IPv6 gives you this opportunity to do sort of mark down individual endpoints and do lots of channels.
Yeah, well, I guess there are different levels of synchronous. I'm thinking synchronous at the macro level, at the big level.
I think people confuse synchronous with deterministic.
Yeah.
You want it to be deterministic. It's usually helpful.
Fair point. Yeah. We were deterministic to video frames because we did a lot of video work, right? So the frame was our synchronization point or line. All right. So okay, no, that's good. Yeah. So I think we've got an opportunity to pull a good proposal together. I need to get some hours behind it. So that's one of the big things I need to start doing. And if I can do that ahead of the game a little bit, so that maybe the framework's a bit more granular for more of the contribution from you guys. But if you can start to put some words to paper, or you can help me out on some of the top-down stuff, any of you, that would be great. I guess being the big guy in the room, Michael Choi at Samsung, I don't know if there is anyone in Samsung that might be interested in helping push this at a greater level, but I guess you can maybe revisit.
I think Samsung were promising an in-memory compute machine for 2027. Is that true?
Yeah, and
maybe we should just go build that.
Yeah, I need to check whether, you know, the internal team to contribute on this piece. So I will get back to you, Alan, actually.
Okay, thanks. Yeah, there's obviously Samsung got this huge effort behind the CXL stuff and the memory related, and being a memory company with all the in-memory type of research they're doing. It would be a nice we provide a nice platform for people to play with all that technology that Samsung are bringing to market. All right, okay. I think that's enough on the New Frontiers response. So I think this is really where our energy needs to go now. So I guess, just in that subject, there's a lot of me that says we need an IBM PC architecture for today's computing world, right? And regular servers are still based on the 1981 IBM PC, so I'm a broken record on that. And we just look at what's going on with DGX, Google TPU, Tesla Dojo, Cerebrus, etc., to see that there's a ton of proprietary architectures that have gone completely away from the classic IBM PC. And I've been saying we just need an IBM PC architecture for today's needs. We don't need to be crazily at the bleeding edge of performance, in my mind, for us to have very capable machines.
Well, I think one of the things is to actually support all the software that's been running on those IBM architecture machines.
Well, and that's the beauty of what we've got here is we can build any machine in history with HPCM, assuming the silicon is available in an HPCM.
Well, its question is, can you virtualize it so that people can't tell that they're on a new machine? Which is what IBM did when they were trying to, long ago with virtualization, was like, oh, we'll do the upgrades so that nobody has to change anything.
Right. Well, my belief is we can wire a machine that replicates Frontier, that replicates a regular PC architecture, that replicates El Capitan, Summit. We can build any one of those machines, given that you put the silicon in those machines into our hardware format, HPSCM format, or E3 and an HPSCM format. We can replicate any of those machines and run those software stacks. And therefore, whatever the software stack is.
But if you can get a 10x performance improvement, then people will rush to use it.
Well, yeah,
that's a trick.
Obviously, being able to replicate any of those machines means you'll get exactly the same performance, because the hardware is configured exactly the same and the software is the same, so everything runs the same, right? So in my mind, a core piece of what we're doing is, because I got slapped around the face for 30 years on this with FPGA computing. It's like, we've got to be able to run our existing code on this new machine as well as, right? So it's a case of hardware-wise, and this is very simplistic hardware that we're doing here, really. It's in a novel, innovative way. But the entire point here is that we can run, that we don't break everyone's software stack. We can rebuild any machine with HPCM. But the way HPCM is architected really plays into what Hennessy and Patterson have been saying. They've been saying we've got to build domain-specific machines for different applications. And with HPCM, we can build any domain-specific machine that's never been built before as well, any configuration, because of its modular, very flexible architecture. So so whilst we haven't broken the ability to run existing hardware and software stacks, we've opened up the novelty for researchers, etc., to be able to build brand new ones if they want for different applications, and mix and match heterogeneously exactly what they need. And heterogeneously in
I think there's this sort of two-pronged thing in this, where you kind of need to tackle the software-defined networking piece and regular code acceleration. So there's an FPGA angle in this one, that if you can get the code running and then look at it and
and I think to your point there, I think if this platform existed, that type of research work and the software angle, people like you would have a blank canvas to be able to do exactly that. And you're absolutely right. I mean, an FPGA module has always been the #1 HPCM module to build, right? And in fact,
but it's still, it's one of those things where FPGAs should be all over the place accelerating code, but they don't seem to be, and that's
well,
kind
yeah,
of the problem.
They have their. That's a big discussion. I've done it for 30 years, so I don't think anyone knows it better than I do.
Yeah, I mean, I've got an architecture that I'd like to do, like, since everybody's keen on RISC-V, let's do a RISC-V/FPGA processor where we just dynamically offload things when we can.
Right.
But that solves one problem. You know, there's three
Yeah, well, exactly.
three
Well, exactly.
problems.
But
You know,
this is where HPCM allows. So somebody with a new
well,
device.
it solves one problem, which is the sort of hardware frame you're in. So it's saying
Exactly.
it's solving the mechanical piece of the networking. But you still have the software-defined networking IPv6 problem of how do we integrate this into, you know, the old code in ways where we get an acceleration.
Yeah.
I mean, and that's in the containerization space. So there's
Yes.
like a containerization sort of Docker Kubernetes thing, which is where you get the software-defined networking in. But then if you do all that, you're still stuck with code running on regular processors, and the only way to speed up regular processors, you know, is the FPGAs.
Right. Yeah. No. Fair enough.
So you got to kind of
Again,
do all that,
just
you know, and go ask the money for money from the government and say, CHIPS Act guys, hey, look, we can do this super machine, but you know, we got to do 3 or 4 things at the same time to make it work.
Yeah, that's and you know, I don't, you know, I want us to focus on this hardware.
I mean, I don't think it works. I mean, I think you have to say, okay, we're going to have to do the new machine with a bunch of different things, but each of those things is going to be something that makes things better on its own. But
Yeah.
you know, only by doing all 3 or 4 are we actually going to give you a machine that does, you know, 10x the performance.
Yeah, but we got to start. So I'm trying to put the framework in place to enable everything you're discussing on top.
I mean, if you look at companies like NVIDIA, you know, it's like NVIDIA does GPUs. The reason they do GPUs is because they've always done GPUs, and they don't know how to do anything but GPUs. So you know, it's like, you know, it's they're not going to make the big leap to something new, you know. So what we're saying here is we'd like to do the big leap.
Well, we want to put the framework in place so the people that can do the big leap don't need $1 billion of venture capital money to do it, like Graphcore and Sam.
I'm kind of let's take the big money and just do the big leap, you know. Like, let's have a go at it.
But I think the VCs have got a little bit of a.
Well, I'm not looking at the VCs, but you know what you look at is like, you know, what is it?
I don't want to get off topic.
Yeah, but I'm just saying that you know, for what you're trying to do, I would say the target is the DoD. You know, they want to have better computers than China does. You know, and China at the moment has the same tech that everybody else has.
For sure. Yeah. But I also, so actually it brings me nicely because Victor's just asked a nice question on the chat. Any development for HPC for edge computing? Knowing the two do not usually stay in the same sentence. So Victor, that was a great plant. If you go and listen to my OCP regional summit presentation, I talk about how HPCM can replace a Frontier machine or be on a telecom box on the side of a Lisbon street, because I got ChatGPT to give me a graphic of a Lisbon street with a telecom box on it, or in your home with a couple of modules so your teenage son doesn't have a kilowatt burning in his bedroom as he's playing his game.
Yeah, not really seeing your high performance compute model working there. But I think there's an issue with the software side of this and the software defined networking of how do I move bits of my system to where they're optimal in the system.
Of course.
You know, if it's optimal to have this stuff working at the edge rather than in the server farm, I should be able to move it there.
But by the way, I look at a computer is not a cloud machine, not an edge, not an IoT. It's all one computer, and the software ideally moves to what the least energy consumption is partitioned itself ideally automatically, whatever way it happens, so that you have at least energy.
So I think the thing with the HPCM is saying, okay, you know, we'll build you the size of machine that's, you know, good for your network, and it might mean sticking, you know, half a dozen modules in a substation of a power plant somewhere, just because that's where you want to do the compute for something.
Right. Yeah. So where you plant it, whatever makes sense for the least energy consumption.
Yeah, but I'd argue all compute's going to the edge.
So no, great. If it does, that's fine. That's absolutely fine. But the thing is, don't dictate it. So my regional summit presentation covers that aspect. That was what was a bit new in terms of the overview of the HPCM module and the wall of compute. So Victor, if you take a look at that, that'll hopefully, and happy to take any questions once you've seen that. Just on the higher power aspects. So I guess what I was trying to say was, I wanted us to have a new open architecture for us all to use. It wouldn't necessarily need to be bleeding edge, but obviously the very nature of we're HPC, everybody thinks bleeding edge. And so I have had the questions of oh, well, NVIDIA now planning on 1.5 kilowatts, or Andy Beckelsstein saying he thinks we can cool 3.5 kilowatts is the limit. You know, so, well, our HPCM module as designed already can take about 3 kilowatts of power in based on the architecture design of the power delivery mechanism. We've currently got it scoped out at 1 kilowatt for the processor and about 0.5 kilowatt for the media or the E3 modules, whatever's in them. And so in theory, we could get there. Power delivery, I think, is a huge issue anyway when you get to these huge currents. So I'm not saying that's going to be easy, but anyway, so we do have the potential for the HPCM module to go north of 1 kilowatt, if assuming you know, it is possible to do. You know, with other technologies, like if NVIDIA can do it in a SXM module, then I don't see why we can't do it in our HPCM module. But the bigger thing that's really been popping out is obviously these chips are getting bigger and bigger with their chiplet architectures, and now, you know, the latest is going wafer scale. So we've seen Cerebras over the last few years doing quite a lot of effort there, and I guess Tesla with their Dojo, by taking known good die, 25 of them, and putting them back into a wafer format with a redistribution layer, and it was announced that they've been working closely with TSMC, and TSMC are now in production, and TSMC are looking at rolling that out to everybody else that wants to do that. Is great. So one thing that really crossed my mind, and I was going to bring up a 3D model of it, is back when Tesla did Dojo, I did actually make a 3D model of their wafer implementation with all the connectors on the outside. I was interested in their interconnect, and we could put maybe 4 modules, sorry, 6 modules. I was calculating if we put 6 modules together in a 2x3 format, we would be able to easily fit a 300mm wafer in there. So tiling wafers together, you know, theoretically, at least from a very simplistic 3D modeling perspective, there's no reason why one wafer scale product module could plug into 6 HPCM sites on the wall. So if the wall was just already built with its HPCM water and power delivery, and 6 times 3 kilowatts is 18 kilowatts. So you'd be able to power an 18 kilowatt wafer scale.
I think you run into the software problem with those things, in that if you try and do wafer scale as wafer scale, then you just have yield issues.
Well, anyway, that's TSMC's problem, and they know how to, their Tesla Dojo is in production according to the TSMC announcement. So, I mean,
I mean,
Tesla has its software stack, so I'm not arguing that point. Again, the software is so. All I'm saying is if the industry is going in that direction, we could by stacking multiple HPCMs together. I mean, we could make a double width HPCM, for example, if a package of the current one went beyond the size of our HPCM. We needed a bigger HPCM. We could do a double width HPCM plugging into the wall.
Yeah.
A wafer scale would be a 2x3, would give us a wafer scale implementation where we could, and that would give us 18 kilowatts of water and power that we could feed into the wafer. So I'm wondering if we can put that in to say, look, we do have a path. If people want to be on the bleeding edge, and they're saying HPCM's we're not thinking about the bleeding edge. Well, we are. If you look at the way they put these Tesla and Cerebras put these wafer scale units, they shove them into a 19-inch rack because that's the world we live in.
I think the Cerberus thing is a standalone box the last time I saw it.
Exactly. And but it's sort of in 19-inch rackish format, you know, because that's
kind of looked like a PC last.
So I was going to try and get that into the top level of the presentation as well, to sort of say, hey guys, there is a path. If you're thinking wafer scale, And I actually did this with Subu. He was at UCLA, and now he's running the CHIPS Act chiplet stuff. So he quite liked the idea, and we were talking about.
I think there's an argument for doing FPGAs as wafer scale, in order to like prototype things you actually want to build. I may go down that path because, I mean, I said to the guys at Cerberus who ignored me that you know, the one thing a good large 2D computer array is good for is simulating a smaller one. So it should be great for chip design.
Well, and ASIC emulation is what we have said is a good first use case of this. If we did an FPGA module, that would be quite easy to do.
Yeah, it's more if you can do like the wafer scale stuff with FPGAs, then you can prototype a whole lot of things.
Right.
And that's sort of part of like OCP.
Exactly. So yes, yes.
So it's the hardware software co-design thing. If like a big array of FPGAs is ideal for chip design prototyping.
Yeah, no, well, and that's one of our first ones that we've said is the first use case is emulation.
And we kind of just do the products and say, hey, we're gonna do HBCM and we're gonna
do
chip design.
We need money to do the product. So okay,
yeah, but that's a full product rather than, you know, half a product. So HBCM as it stands is like half a product.
Yeah. So that's the first use case potentially that we're.
Yeah, but I would go for the use case. So,
yeah. Well, I guess we've been talking about that for months or years. In fact, an emulation platform would be a good starting point for various reasons, both for CXL enablement and chiplet enablement as well. By the way. Anyway, we're past the top of the hour, so thanks everybody. I'll keep you posted as we make progress, and you know, you should have access to the document. I think it's still going to be at the bottom of the minutes. There's a links to the document. If you feel you can put some more words in your particular area, please do. And see you all in 2 weeks' time.
Hey, Alan, could you shoot us an email? Let us know when you update the kind of the high level view of this thing, kind of the high level structure, and then possibly even send it out to me or the link to download.
Well, so everybody can see at the bottom of every minutes I've published, there is a link to the work in the RFP.
Yeah, no, all I'm saying is this: when you add your high level bits to it, can you send out a link to us so that that's done?
Yeah, I'll let people know.
Awesome, thank you, sir.
Alrighty, okay, thanks everybody.
Cheers.
Thank you.
Bye.
Have a good day.